All right, finishing the multiplication example. So we have that second row, first column, entry was 139. Okay, and then we have our last, which is row 2 by column 2. So we have 4 first entry times top entry. So we have 4 times 8. Okay, and of course this one is second row, second column. That's going to go in the second row, second column. So 4 times 8, and then 5 times 10, and then 6 times 12. So it's very action-oriented, as I said up here. So it's across and down, across and down, across and down. And then we add those products. So we have 32, 50, 72. So we have 32 and 72 makes 104 plus 50 makes 154. Lots of scratch work with this, guys. And that's our answer. Okay? All right. So that's the physical action of multiplication. It's not bad, it's just strange. You multiply across and down. Across the first, down the second, always, no matter what. And it takes practice because each time you multiply matrices, the dimensions change, which makes it feel different until you've kind of gone through multiple examples. So this is one of those rare times where you really do need repetition because there's not a lot of repetition. There are a lot of different combinations, and it can feel weird when you have a different set of matrices to multiply. All right, so it is important that you check the dimensions before you multiply. You can't just multiply any two matrices. The sizes or dimensions have to match in a certain way, and here's how they have to match. So the first matrix in this problem that we just worked was 2 by 3. The second matrix in this problem was 3 by 2. Okay, this is important. The only way you would be able to multiply two matrices is if the number of rows and the number of columns, right? That's going to give me, that's going to give me the size of the actual answer, right? But for you to be able to actually multiply, you notice we had 3 entries across and 3 entries down. These numbers have to match, right? If those numbers don't match, right? If the second dimension of the first and the first dimension of the second matrix, if those numbers don't match, it's incompatible. You cannot multiply. All right? And we'll see an example of that. So let's do another example, and what I just said will make a little bit more sense. Okay, let's dive into. All right, so I'm going to work part A times B, and then I'm going to let you work B times A, and I do want you to see that multiplication of matrices is not commutative. That means when you do A times B and you do B times A, you get different answers. Okay, that's not true with numbers. 5 times 2 is the same as 2 times 5 with just regular real numbers. They have that commutative property that you learned back in middle school. Not true with matrices. So one of the standards isn't just to operate on matrices like you see at the bottom of the slide. It's also when do matrices behave like real numbers and when do they kind of operate as a completely different system of the operations behave differently. And in this case, we see that with multiplication, or we will see multiplication for matrices behaves differently than multiplication for real numbers. All right, so we're going to do 5A, okay? Then we'll do 5C, and then I'll let you do parts B and D, and I'll give you the answers at the end of the second video. All right, so let's do A times B. I'm going to do this much faster than I did before, just to kind of show you that it's very much a physical act of kind of sliding your fingers here and there. Okay, so I'm going to show my work, right? You'll be able to use their calculator, but you will have to show work. We'll talk more about that in class. All right, so we're going to multiply our first row by our first column. So we're going to multiply across and down. So 4 times 0 is 0. Negative 2 times 2 is negative 4. That's my first entry. We'll do something with that in a minute. Then we multiply our first row by our second column. 4 times 4, 16. Negative 2 times 3 is negative 6. There's our second entry. So because we have 2 across and 2 down, we're going to multiply twice, all right, per entry. Now we go to our second row, first column. 3 times 0 is 0. 1 times 2 is 2. We're going to add those. And then we have our first row, our second row, and our second column. So 3 times 4 is 12. 1 times 3 is 3, and we add. Okay, so 0 and negative 4 is negative 4. 16 and negative 6 is 10. 0 and 2 is 2. 12 and 3 is 15. Final answer. Okay, so that's part A. I'll let you try part B on your own. All right, so let's jump on C. Okay, so let's see D times C, and I'll let you do C times D. Okay. All right, so D times C. So we'll do this part. I'll let you do the others, and I'll give away the answers. So let's rewrite it. So you can see another combination. D times C. Okay, so we have a 3 by 2, and we're multiplying that by a 2 by 3. We have 2 across and 2 down. This tells me that I can actually do the multiplication. Those numbers match. But what that means is the answer is going to be a 3 by 3. Okay, so I'll do the scratch work here, but I know I'm going to wind up with a 3 by 3. So it's kind of nice to know before you start multiplying so you can kind of space everything out. So I'm going to do across and down. 4 times 1, 1 times 4, and I'm adding those. First row, first column goes in the first row, first column. Then I'm going to go across and down. So first row, second column goes here. So 4 times negative 3, 1 times 2, and I'm adding those. Then I go across and down. 4 times 1, 1 times 4, and I add. Okay, so I'm done with the first row of the first matrix. Okay, so now I'll change colors just to kind of draw attention. So I have now second row, first column, so negative 2 times 1 is negative 2. 5 times 4 is 20. I'm going to add those. So now I have second row, second column. Negative 2 times negative 3 is 6. 5 times 2 is 10. Add those. Second row, third column goes in the second row, third column. So negative 2 times 1 is negative 2. 5 times 4 is 20 again, and I'll add those. Then we move on to the last. Bloop, let's make it orange. So we have third row, first column. 3 times 1 is 3. Negative 2 times 4 is negative 8. Third row, second column. 3 times negative 3 is negative 9. Negative 2 times 2 is negative 4. Third row, third column. 3 times 1 is 3. Negative 2 times 4 is negative 8. Okay, so we have all of the work. We've shown all the work. Now we just need to simplify. So the first entry is 8, negative 10, 8, 18, 16, 18, negative 5, having flashbacks of doing times tables. 3 minus 8. Boom. Final answer. Okay. So guys, I'm going to go to, so if you want to try part B on your own and part D on your own, and you can pause the video now, try B, try D, and I'm going to flash the answers. All right. So guys, keep working hard, start the semester strong. Here we go. So the answer to B times A is 12, 4, 17, negative 1. And the answer to part D, which is C times D, and I have the work here so you can pause it and check it out. Final answer is 13, 16, 24, and 6. Guys, I hope that wasn't too painful. I will see y'all in class. And like always, reach out to me if you have any questions.